Okay, so today we're going to be doing more with conditional probabilities, and here we're going to have kind of a formula that works with us. So these are all going to be times that I have two separate events here, and so what I can do is, again, still in the same way, where the A is going to be the thing that happens first, and the B is going to be the thing that happens second. All I have to do is take the probability that the probability of A and B happening at the same time, and then divide it by the probability of A happening here. So with the first one, we have a new drug. Half the volunteers take the drug, half the volunteers take a placebo, which is like a fake. Probability a volunteer receives the drug and gets well is 45%. So I want to find the probability that someone getting well, given that first he receives the drug. So that's what I'm going to have first, and then getting well is what happens second. So again, when I write this out, I'm going to go the probability of getting well, given first that I receive the drug. So to do that, I want to find out what's the probability of getting a drug and getting well. And it says in here that 45% of the people received the drug and got well, so I know that'll be 45%. And then the probability of someone actually getting the drug, which is the other part that I need for my formula, said that half the people got the drug, so that'd be 50%. And so again, these are the only two things I need. I'm just going to divide both things happening at the same time, divided by probability that someone gets the drug. And so I can go 45 over 50, which reduces down to 9 over 10. And that would be 90% chance that a person is given the drug and they get better. In the same thing, volunteer receiving the placebo, having her health improve was 20%, so I want to find the probability that someone's health improved, given first that they actually received the placebo. So again, I'm finding the probability that someone gets well, but now what I care about first is that they receive the placebo. And so again, when I do that, I want to find out the probability that someone got the placebo and they got well, which again it said right here was 20%. I want to get the probability that someone got the placebo, which in this case, again, half got the placebo, half got the drug, so it's going to be 50% again. And then, again, I can just divide the and by the placebo to go 20 over 50, which reduces down to 2/5, and that gives me 40%. Similar type problem. So in a survey of pet owners, 45% people own a dog, 27% own a cat, and 12% own both a dog and a cat. So with the first problem, I want to find the probability that a dog owner also owns a cat. And so again, the way that that's worded, that a dog owner, that's what I care about first, also owns a cat. And so I'm going to have dog owner, that's going to be the thing that I care about first. Cat is going to be the thing that I care about second. So when I write this, I'm going to go probability of cat. But what I first care about is that they have a dog. And so again, probability that someone has a cat and a dog, is going to be 12%. Probability that someone just owns again, this one's going to be dog, because that's what I care about first. It says 45% own a dog. And so again, I'm going to divide the and by the dog. So the and is 12 over the dog, which is 45. So So it reduces down to 4/15. When I do that, I get 26.7%. And then with the second one, I want to find the probability that a cat owner also owns a dog. Again, cat owner is going to be the thing that I care about first. Dog is what I'm going to care about second. So the probability is like backwards of each other. So probability that someone has a cat and a dog is still 12%. And then the probability that someone has a cat this time is what? 27%. And so again, I can go 12 divided by 27, which gives me 4/9, which is 44.4%. Just like that. And the two problems at the bottom, so again, same survey showed that 5% of pet owners own a dog, a cat, and some other type of pet. So I want to find the probability that a pet owner owns a cat and some other type of pet, given that they own a dog. So they need to have a dog first, and then they are going to own a cat and some other type of pet. So remember, if it first matters that they have a dog, and then that they own a cat and some other type of pet, they're going to have a dog, a cat, and some other type of pet, which is how I'm going to use this 5% right here. So the probability that they, again, first is dog, second is cat and other type of pet. So I'm going to go cat plus, given that first they have a dog. And so probability that they own a cat and something else and a dog is going to be 5%. And then the first thing that I care about is probability that they have a dog, which is 45%. And so again, I can go 5 divided by 45. Reduces down to 1/9, or 11.1%. And then the second problem, same thing, still finding conditional probability. See that we're given in there, so cat is what I care about first, and then owning a dog and some other type of pet is what I care about second. So probability of dog and something else, given first that they own a cat. So the probability of a cat, or oopsie, a dog plus something else and a cat, still going to be that 5%. It's all three of those conditions. And then the probability that one of that first they are a cat, they have a cat, again, is going to be 27% from the top. And so I can go 5 over 27, and it gives me 18.5%. So the next two problems, again, these are going to be slightly different. So when I'm looking at what they're asking, I want to find the percent of freshmen that graduated. And so this is going to be a little bit different because this isn't necessarily going to be conditional. I'm not going to use my formula, so this one's going to be not conditional. And so what I'm going to do actually is I'm going to make a tree diagram to kind of help figure out the probabilities of each thing happening, because they only give me certain information. So what percent of freshmen graduated? If I'm looking for graduated, that's going to be the last thing that I put down in my tree diagram. So what I'm going to look for first is what other information that they tell me. So, you know, they tell me 80% graduated, 60% attended public school, graduated. 70% of freshmen attended a public school. So I'm going to start with public school. So I'm going to actually break this up into two different columns, or two different kind of branches. So if the person went to public school, or if they went to something else. So if they went to public school, it was 70%, so 0.7 of the freshmen attended public school, which means that for the other half of it, there would have to be 30%. Then from the public school, it tells me that, again, I'm looking for graduate and not. So it tells me that, let's see, 60% of freshmen who attended public school graduated. So this is going to be 0.6, and then this would be 0.4. For the other schools, it tells me 80% of other freshmen graduated within 5 years. And so, again, grad and not. So this will be 0.8 and 0.2. And so, again, what I want to find out is I want to find out if they graduated or not. And so what I will do is I can take the percent that graduated, times it by the probability that the person went to the public school. So the probability that someone went to public school and they graduated, and I'm just going to multiply these guys by each other. Again, these two independent events, and so to find an and, I can go ahead and multiply the probabilities by each other. So I can go 0.6 times 0.7. When I do that, I get 0.42. For the next one, I can do probability that someone went to some other college and they graduated. Again, I'm concerned about graduation. And so again, 0.8 graduated, and then 0.3 went to that other high school. So again, I'm taking the graduate and I'm multiplying it by the percent that went to the other type of high school. And so 0.8 times 0.3 gives me 0.24. So what I can do is to find the probability that freshmen graduated, I can actually add these guys together. I can add together because I'm looking for an OR equation from this. I'm looking for people that graduated from public or they graduated from an other. So that would be 0.24 plus 0.44. Oopsie, 42. So when I add those together, I get 0.66, which is 66%.